Okay, you guys, number 3 on our review sheet, some more calorimetry here. So this is just like our specific heat of a metal lab. So during the coffee cup calorimetry lab, students measured the temperature of a 75-gram sample of a metal to be 82 degrees Celsius. They then added it to 95 milliliters of 23.0 degrees Celsius water. The temperature of the water increased to 27.5 degrees Celsius. So we want to know, what is the specific heat of the metal? So first, we're going to figure out what we need. We need a specific heat. So specific heat is equal to the heat over mass times change in temperature. Now, remember, it is hard to find this of the metal, so we are going to use the water to help us. So first, we're going to find the heat that the water absorbed. So to do this, we're going to take the mass of water. So we have 95 milliliters of water, which is going to translate to 95 grams. It's liquid water, so our specific heat is 4.18 joules per gram degree Celsius. And then our change in temperature, it started at 23 and went up to 27.5. So that's a change in temperature of 4.5 degrees Celsius. So that means that the heat that the water absorbed was 1,786.95 joules. Now that's not what the question asks. That is going to help us relate. So remember, we're going to make an assumption that the heat that the water gained is equal to the heat that the metal lost. So we're going to use the negative value of that Q, and we're going to plug it into our specific heat equation that we found in part 1 to find the specific heat of our metal. So negative 1,786.95 joules, and then it's going to be the mass of the metal. So we have a 75-gram sample of metal, and the temperature change of the metal. So it started at 82 and ended at that 27.5 degrees Celsius. So 27.5 minus 82 is going to be our change in temperature. So the specific heat of this unknown metal is 0.437 joules per gram degree Celsius.